My name is Lucas, and I'm an engineer on Google Web Designer. In this video, I'll show how to animate objects along curves using motion paths. Previously in Google Web Designer, if you wanted to animate an object position, it could only travel along a straight line, like this. Now, you can have it move along a curve by simply grabbing any point on that line and dragging it. We call this resulting curve a motion path. You can edit the shape of the motion path by moving any point on the curve's interior or by moving either of the endpoints. You can also have the object face along the motion path as it travels by going to the Property Inspector and in the Motion Path section checking Orient to Path. So here's what that looks like, and here is the final animation. To get more control over the shape of the motion path, you can use the Motion Path tool. With this tool, in addition to moving the curve directly, you can also move tangent controls, and by changing the tool mode, you can insert control points, like this, and you can delete control points, like this. By default, when you move a tangent control, the opposite control also moves to preserve the smoothness of the curve. If you don't want this behavior, and you want to add a corner to the curve, then you can hold down the Alt key if you are on Linux or Windows, or the Control key if you are on Mac. You can get a similar effect by double-clicking on a control point. That will shrink the tangent handles down to 0 length. You can then double-click again to re-extend the handles. Finally, if you want to create a looping motion path, you can simply grab the endpoint and drag it towards the start, or vice versa, and they will snap together. So here is a smoothly looping motion path. To control the timing of the animation, you can use the timeline. And to demonstrate this, I'm going to go back to a simpler version of this path. That's just a bump. So I'll readjust these tangents so that it creates a little hill like this. Okay, great. So right now the timeline has the second key at 2 seconds. So if I play the animation, it takes 2 seconds to complete. I can slow down the animation by moving that key out to, say, 3 seconds. And now the object travels along the same curve, but at a slower speed. You can also add acceleration and deceleration by changing the easing function between the keys. So I will pick an easing function here that causes the object to gradually come to a stop at the end of the path. You can get more complicated effects by using multiple keys. So for example, I will add in a second key here, and I will move the object out a little bit, and then adjust the path so it's smooth. And then finally, I will change the initial easing function so the car accelerates from a standstill. So with these changes, we now see that the car accelerates over the hill and then travels at a constant speed. Motion paths animate using X and Y translation. So if you edit X and Y translation, you edit the motion path. For example, if I go here and I change X to a different value, I will see that I get both a key in the timeline and a new control point on the motion path. If I then edit, say, Y, or I even go to the selection tool and I directly move the object, that control point now moves. All of the other transform channels, however, Z translation, rotation, and scale, those all can be animated independently of the motion path. So to illustrate that, let's say, if I go back to the original path shape, that I want the car to shrink in size as it goes over the hill. What I can do is I can go to the end of the animation, and then with the selection tool, I can shrink the car down. To make the animation happen over the entire extent of the time range, I'm just going to remove the middle scaling key. And now if I go back and I play the animation, I see that it's the same as before, but this time the car shrinks as it moves over the hill. I'd like to conclude by saying a little bit about how we represent motion paths internally. Like all other animation generated by Google Web Designer, motion paths are entirely constructed using CSS. Now, CSS cannot be used to exactly represent a motion path. So instead, we have an optimization process that approximates the motion path to subpixel accuracy while minimizing the amount of CSS that we generate to minimize the storage footprint. So in the property inspector, you can see the tolerances that we use for the optimization. We always stay within half a pixel of the ideal position and within 1 degree of the ideal angle. Now, at author time, to keep interactivity, when we run the optimizer, we use settings that cause it to finish quickly, but perhaps using more CSS than is strictly necessary. If you want to squeeze out some space, then you can rerun the solver with settings that take a bit longer to complete, but that usually improve the amount of CSS that's generated by clicking this button labeled Optimize Curve. So right now, the estimated compressed size is 346 bytes, and if I click this button, then it goes down to 300 bytes. That's all I had to say about motion paths. Thank you for watching.